I want to think about binomials. This is a binomial, right? Binomial just means it's got two terms in there and it's raised to a power of some kind, okay? So this is often also called binomial expansions, but it includes more stuff than just expanding stuff. That's why it's the theorem, okay? It includes things like this, okay? So let's have a look at the basic expansions. This is, we're moving past the properties of Pascal's triangle now. Basic expansions, okay? Let's think about, as a classic example, I need a new color. Let's take a binomial expansion with an index of 0. Okay, we'll start with 0 because 0 is a good place to start and Pascal's triangle starts there too. Okay. If I take a binomial, a simple one, like say 1 plus x, okay, and raise it to the power of 0, what's it equal to? It's just equal to 1 because anything to the power of 0 is equal to 1. You could even argue, there are good reasons why you can argue 0 to the power of 0 is 1. There you go. Okay. Index 1. Okay. This is not too hard because the numbers are still small. 1 plus x to the power of 1. It's 1 plus x, right? Okay, now keep going. How far do we need to go? I'm going to go down 2, 3, let's go up to 4, I think. Okay. Now, actually, I'm going to need some working out space. So let's do 2, 1 plus x all squared. Now, you know how to do quadratics because we've been doing them for a long time. So you could probably, with no working out, tell me what the result is, right? It's 1 plus 2x plus x squared. Next row. Next index. Now, when you're cubing numbers, we don't do them so often, and we don't usually have to expand them so often either, okay? But let's do it. Let's give it a go. I can see that as 1 plus x times 1 plus x all squared, which is this, right? So I'm just going to include that expansion there. Is that all right? Yeah. So now we'll do one of them, which is this, and then I'm going to do x of them, which is this. Okay. What do I get? There's still just the 1 out the front. There's only ever that one constant, right? How many x's do I have? I have 2 here and I have 1 there. Why do I have 2 plus signs? That's funny. So I'm going to get 3x there, right? How many x squareds? 3 again. How many x cubes? 1. Okay. When we were doing the sums of all these coefficients, we got to like here, and then we said, okay, fine, I can see a pattern here, right? So, can we do the pattern? What would you guess if we raise it to the power of 4? Do we have to do the working? Look at your Pascal's triangle carefully. I've got mine here, you've got yours there in front of you, okay? I'm predicting that I'm going to start with a 1. Every time, I'm going to start with a 1. Okay? Now, I'm writing it. You can see the way I've written it is because my 1's first and my x is second, I'm writing with the powers of x ascending, right? So my first power of x is just 1. How many x's to the power of 1 am I going to have? I predict 4. How many x squareds? 6. How many x cubes?
4.
Back down to 4. How many x to the 4s? Just the 1. Okay, let's do one more, just for the sake of writing it out. Can you see, by the way, you know how I said to you, oh, you're going to need to memorize this number of rows, and you thought, wow, memorizing number of rows, that's crazy. Well, when you start writing this a few hundred times, it starts to get in there, okay? So, I'm not expecting that you're going to have to stand in front of the mirror and recite these to yourself. I think after doing the work, you'll get it, okay? So, what are you guessing? How many x's? I'm guessing 5, and then 10, and then 10 again, and then back down to 5, and back down to 1, okay? All right, now here is my question, okay? You've done some basic algebra, you've seen a pattern, okay? You're guessing that it's the case, and it's a good guess. Now my question is why? Why are these numbers, right? This one, these ones, these ones. Why are they the numbers that we just saw? Okay. Now, I'm not going to ask you to explain it, but does anyone have any ideas in their head right now of why on earth this would actually happen? Anyone? I'm not going to ask you to do it. I'm just curious to see if anyone's there mentally or not. Okay. Yeah, do you think you have an idea?
Is this something to do with probability?
Yes, it is. Kind of. Probability is about how do you work out the probability of something? You say you've got a fraction, don't you? You've got favorable outcomes over total outcomes. So there's always fractions involved. There are no fractions here, but the same numbers are important. Those favorable outcomes, total outcomes. Okay, so kind of yes. That's a good guess. I did give you a bit of a clue before, right? We've actually not helped ourselves here. The reason why this doesn't look as obvious as it is because we have done a lot of shortcuts, okay? So underneath this, I want you to rule this off, and we're going to do this again, but we're going to write it in, I hope, a more helpful way, okay? A way that will make the pattern, why this gives you these, makes it more obvious, okay? So, I am rapidly running out of room. I'm going to try and do it in here. Okay, this is the line I'm going to start with, okay? You gave it to me straight off, okay? Because you know that result, because you've done it for so long, you've been doing it for years, okay? But where does it come from, okay? This is back to index 2, row 2. When you say 1 plus x squared, what does it actually equal to? Like, what does the squared mean? It means multiply again, right? It gives this. Okay? Now, when you first learnt about brackets and how to expand them, right? What you learnt was, well, you might have learnt FOIL. Do you remember FOIL? You go first, outside, inside, last. And you have to do all of the matching up, right? You got to do, it's kind of like two people saying hello to coming into a house with two other people, right? The first guy says hello to these guys, right? And then the second guy says, because, you know, he doesn't want to be a jerk either, he says hello to these two guys, and then you end up with those 4 terms, right? Now, you have learnt that some of those 4 terms can be combined, and that's why we didn't end up with 4 terms. We ended up with 3, okay? But there really are 4 terms there interacting with each other. Let me show you, okay? Write this with me, okay? The first one, the green ones, that's one lot of 1 plus x, right? And then you've got x lots of 1 plus x, okay? Now these 4 terms, why is it that they collapse into 3? Well, it all depends on how you write it, okay? I think from here, right, these 2 terms, my colors are gonna go crazy. These 2 terms, no, wrong one, sorry. That's red and that's green. Okay? They become, well, this one becomes a 1 and an x, right? A 1 and an x. These guys become an x and an x squared. 4 terms. And now you can kind of see why 4 terms become 3, because they're like terms. That's why we collect them like this, okay? Aha. But can you see what's happening? Can you see Pascal's triangle in here, right? It's a 1 and a 1, right? Gives you this number in here, right? That's in here. And then you've got these 2 guys off on the edges. They've got no one to add to, right? I've got no one in common over there. And so I just end up with a 1 and an x squared, like this. Can I say that again? Maybe I wasn't clear, okay? This one, he's like, I want to add to someone, but I've got no one there. Just like this guy, right? He looks around and all he's got is that. So that's why you end up get one of him, right? This guy's like, well, I've got 2 to add from, right? It literally comes from these 2. And that's why it turns into 2x. This guy does the same thing as before. Can you see what will happen if we do it one more time? Let's do it for index 3. This is going to be messy for me because I've run out of space. I'm going to wrap up a few things. Hope you don't mind. Not that kind of messy. Sorry. I'll do it right underneath where I had it before. Okay, because I'm almost there. Okay, let's do this expansion and see if we can see what's going on in here. Okay, so Sorry. 1 plus x cubed. Okay. How will I write it in such a way, like I did here, to make the pattern obvious? Well, I think it's 1 plus x times 1 plus x squared. Are you happy with that? But I know that, just like here, okay, this is 3 terms, like this. Okay, so I'm going to write that line again. But now, instead of going straight to here, right, I'm going to write it out in a way that shows this kind of relationship. Okay, so I'm going to write it like this. 1 plus 2x plus x squared. That's the first expansion of this. And then I'm going to write this guy, x plus 2x squared plus x cubed. Can you see it? Can you see it? Look at the different parts. The 1, right? This guy here, I'm looking at this row. This 1, he looks for things to add up into, right? And there's only 1. That 1. Empty. So it ends up with just 1. The x's, they look around for who to add up to. Okay? There's a 1 and a 2. 1 and a 2. These guys, right? And that's why you get 3. Oops. Okay? The x squareds do the same thing, and just like from before, there was a 2 and a 1. That's where this expansion came from, right? And so that's why you end up with 3x squared. And of course, that x cubed off on the end, he is lonely just like the 1 is. Okay? And the pattern continues from there. So now, when you have a look at these guys, and if you make the powers really crazy, well, you can make the powers up to 10 off of your diagram, right? And you can just read off the coefficients because you know they followed this pattern. You've done all the work to construct it when you constructed the triangle, okay? And so you can quote these results. You don't need to do any of this monkeying around, just like you don't need to do any of this monkeying around. You can go straight there because you know this result. Well, now that you've established the connection between this and all of this, now you know all of these results as well. Does that make sense? Cool.